Hello, dear learners. I am welcoming you all after a long break on the demand of the loving students. I am here again with the chapter Gravitation for Standard 9th. So, as the time is short for the final exams, so I'll be starting with some conceptual based questions. And today we are going to start with some case study based questions, and they will be helping you with the clarification of the concepts, right? So, here we are going to start with, though maybe they will not be there in the exam, but they will definitely be helping you for the clarification of concepts. So these are case study based questions, right? That means a paragraph will be given, and in that paragraph some particular hints will be given, and from those hints we are going to reach to our particular answer. So let's start with it. We know that the moon goes around the earth. An object, when thrown upwards, reaches a certain height and then falls downwards. We know this thing, that whenever we are throwing something in the upward direction, ultimately it has to fall down. And it is normally being said that we have also read that when Newton was sitting under apple tree, fine, an apple fell on him. The fall of the apple made Newton start thinking. What he thought? He thought that if the earth can attract an apple, can it not attract the moon? कि क्या अगर एप्पल को अट्रैक्ट कर सकती है अर्थ तो मून को अट्रैक्ट नहीं कर सकती? Is the force same in both the cases? He conjectured that same type of force is responsible in both the cases. उसने क्या conclude किया कि same type of force ही है जो दोनों cases में responsible है, right? He argued at each point of its orbit. उसने क्या कहा कि हर एक point पे ये चीज जो है वो applicable है. Orbit means a circular path motion, right? And the moon falls towards the earth instead of going off in a straight line. कहता है मून भी क्या होगा, उस अर्थ की तरफ फॉल करेगा instead of going in the straight line path. So it must be attracted by the earth, but we do not really see the moon falling towards earth. पर हम क्या है, हम मून को अर्थ की तरफ फॉल करते हुए नहीं देखते. क्यों नहीं देखते? This discussion will have in the later lectures. Let us start with some of the reasoning questions here. First is Newton's law of gravitation is valid. Newton's law of gravitation is valid on the earth only, on the moon only, in the lab only, or everywhere. Definitely, my dear students, it is applicable everywhere. ठीक है, न्यूटन्स लॉ ऑफ ग्रेविटेशन इज एप्लीकेबल on all the bodies which are either celestial or terrestrial. Means it is applicable, it is valid everywhere on the earth crust, right? Everywhere, though it can be a space, rather I should say the body is celestial or the terrestrial body, right? Now the next is the universal constant of gravitation G has unit. See बच्चे, what is F? F is given by G m1 m2 over r square. We have to find out the unit, universal constants unit we have to write. That means we want to find out the value for units for capital G. Then it will be coded by F r square over m1 m2. We know that unit of force is Newton. Distance unit is meter. As r square is there, so unit will be meter square. Here mass unit is kg, but the two masses are there, so unit will be Newton meter square per kg square. I hope this is also okay to you. ठीक है. One thing you should make sure in case study based questions, it is not mandatory that every answer you are going to get from the paragraph itself. No, they are actually critical reasoning based questions, right? So you should know the topic beforehand only. Now next you see the equation F is equal to gm1 m2 over r square is valid for this equation. This force of gravitation, it is applicable for rectangular bodies? No. Circular bodies? No. Elliptical bodies? No. It is applicable for all the spherical bodies which are spherical in shape. Then next question is, two particles are kept at a separation r. Two particles are there. Let this particle be A, this be B, and they are kept at a separation. That means their distance between them is r. Then the gravitational force is proportional to, we know बच्चे, F is directly proportional to the product of the masses, and it is inversely proportional to the square of the distance. That is, F is inversely proportional to square of the distance. इसका मतलब क्या है, जितना distance बढ़ता जाएगा उतनी force of attraction कम होती जाएगी. So that is option D is correct. That is 1 upon r square. Right? Now next you see fifth question is, the force of gravitation between the two bodies of mass 1 kg each kept at a distance of 1 meter is. अब आपने क्या बताना है, force of gravitation between the two bodies. Force of gravitation between two bodies is given by which relationship? It is given by F is equal to gm1 m2 over r square. Fine. So if mass, both the masses are 1 1, distance is also 1, so what does this implies? F is equal to g, one mass is 1, other mass is also 1, distance square is also 1, so F will be equivalent to g. So what is g? G is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. This is the value of g, but we want the value of f, so f will also be equal to 6.67 into 10 raised to power minus 11 न्यूटन. अगर ग्रेविटेशनल की वैल्यू हमने निकालनी होती तो ये वैल्यू और ये रही उसकी यूनिट. ठीक है, बट यहाँ पे है फोर्स की वैल्यू निकाल रहे हैं तो फोर्स की यूनिट क्या है, न्यूटन. दिस इज अगेन अ वेरी इंपॉर्टेंट क्वेश्चन, सो ऑप्शन डी इज द करेक्ट वन. Right? I hope you all have understood this lecture. I'll be updating the next video very soon. Please stay in touch. By that time, stay blessed and stay healthy. Thank you.